Since DerbyCon 5.0. It doesn't change.
All right, just you're picking up audio.
Back. Okay, good.
All right, cool.
All right, so we're back. We're going to go ahead and get started. So we got lunch coming in at noon. All right, so we'll go ahead and get started. Matt, you're up. I'm going to let you introduce yourself and your sidekick.
All right.
And let you guys get going. Short rounds.
Okay, everybody. My talk today is called These Artifacts Aren't Fiction. It's not just my talk. I'll have my co-speaker introduce himself here momentarily. So, for those of you who may not know me, and I think most of the room probably does, but if you don't, my name is Matt Scheurer. I work for a big, well-known organization that doesn't let me talk about it, but I'm an AVP of Computer Security and Incident Response, but I've got a lot of years of hands-on technical work, digital forensics, incident response, that kind of stuff is where my specialty lies, if you will. With Micah Brown there, we are the Threat Reel podcast. We've been on hiatus for a bit, but we're getting ready to change that here soon. And so if you're not connected with me on LinkedIn, hit me up out there. And you can also get me on Twitter at C3RKAH. I'm sure Pedram's going to give me a follow back, right? All right, so with that, do some volunteer work. I'm an official Hacking is Not a Crime advocate, and then I'm also a WAMSA technical mentor. WAMSA is the Women's Security Alliance. Always looking for mentors, mentees. Great organization. Check it out. Get involved if it's calling to you. I'm going to turn it over to my co-presenter here for a bit, and then we'll come back to me.
Okay, cool. Well, my name is Tuan Phan. This is my second time in the Dayton area. Thanks for the OISF for having me here with the rockstar himself. I'm an independent info security researcher. I also work in a big, well-known organization. I can't speak either. So I'm also an AVP to e-discovery, forensics investigations, / insider threat strategies. With that, yes, me and Matt here, we do have our day jobs. However, our opinion is expressed are basically solely on our own independent security research, and it does not express or reflect the view of our employers. So therefore, we are not lawyers. We're not driving Lamborghini or Ferrari. Last time I checked, we drive a Toyota. So this presentation is for educational purposes only. Please kindly consult with your qualified legal counsel before using of any of this, these techniques in your actual investigations or incidents. Due to the constraints of time and of our topics, this is out of scope. Third-party forensically sound, such as the memory capture, aka memory dump, there's imaging tools such as FTK, NCase, all the other stuff. We're not going to talk about the chains of custody or court case and trials, data handling, and acceptable practices, isolations, remote access, and when to disconnect or shut down your workstations during the incidents, data storage, data archival, and data write blocker. We'd be happy to talk more about it after our presentation. We'd be standing back there or during our breakout sessions. So come to us if you need to talk to any of those topics. With that, I'm going to turn it over to Matt. Let's talk about the data preservations and his front data.
All right, thank you, Tuan. And for anybody here in person, feel free to join us at the Troll Pub in downtown Dayton after this event. We can talk about all kinds of forensic stuff after the conference. We'll be there probably about 30 minutes-ish after the conference officially adjourns. So, just some notes about data preservation methodology. First, you want to collect a forensic image. That's the most important thing. That's working from a forensic clone, which is a working copy of your forensic image. So you have an unaltered image, and you're working from a copy of that. that. And then after completing and hashing a forensic image, really that copy process takes time. It takes time to do the hashing. That really is probably a good point in time to start doing live acquisition type activities and getting a hold of, some of the things we're going to talk about here. And really, what's important is to minimize activities that could modify system data, access times, as much as possible. And really, that's what this talk is focused on. So I'm going to start things off talking about the Windows SRUM database. The System Resource Utilization Monitor, or SRUM for short, is built into Windows 8 and above. It's the system app history data. It gets recorded and stored in an ESE database named the srudb.dat file. That particular file lives under the Windows System 32 folder /sru/srudb.dat. Think of the SRUM database as holding the same level of details typically found in most commercial EDR, XDR type platforms, but without the monitoring, the alerting, detection, or response capabilities. Now, some people have said, well, should I use this instead of the SIM? No, I would say use this in conjunction with your SIM. Use this in conjunction with things like Sysmon, if you have those things. Or if you don't have those things, or you encounter a situation where those things either aren't there, not working correctly, this is a great backup to fall on. Now, useful SRUM data. Okay, so the SRUM database was never intended to be used for forensic purposes by Microsoft. Consequently, more details are stored in there than you would ever actually find useful in a real-life investigation situation. So we're going to focus on the two ones I think that have the most forensic value, which are the application resource usage and the network usage. And so some free and open source options are the SRUM Dump 2 application out there on GitHub. It can be a little tricky to if it's not running right out of the box to get it running. Velociraptor is a open source project now basically managed by Rapid7. Thank you, and tell your Velociraptor team, Daryl, thank you. Nearsoft has some great free well, they're not really open source, but they're freeware applications that you can use for all kinds of stuff, but they've got some cool forensic capabilities. And so specifically, I'm going to talk about the application resource usage view and network usage view. And there's links to those. And again, if you don't have the slides, rather than frantically, if you go to slides.dfirmat.com, you can get a copy of this slide deck. It's out there right now. So feel free to grab a copy of that, and all these are hyperlinked, get you right where you want to be. Here's just kind of a quick example of the srudb.dat. And so it's probably a little hard to see here, but basically you got your record IDs. Your next column is the timestamp, which is very important for forensic investigations in order to timeline events. You have the application name, which will actually give you the path as it relates to on disk, and then it assigns everything in app ID. And then you have the user SID, which again is really useful for attribution. So you can understand when you're looking at this, you can tie it back to who did what, or at least under which user context something may have executed under. Here's a quick screenshot example, hopefully a little easier to see. Now the Nearsoft tools I talked about, you can either use it for the live SRUM database, or you can actually make a copy of it and then use this to view it offline. Now, if you're looking online, or you also dump out the registry, you get more detail than here. Here's like the worst case scenario offline, and you don't have the registry dump. Yeah, basically you're getting the timestamp, the application name. You've got the user SID as we talked about. You can see the time. You can also see bytes that are written and read, which is useful because if you're looking at something and you have an idea what it may have done, you can or if you're not sure, you can see the bytes involved there and get a better picture of this might be worth digging into a little further than something else. Network resource usage, same type of deal. You'll get timestamp data, a description of the app or the service that basically ran. Again, ties it back to the user SID. The network adapter specifically. So if you had multiple adapters, say Wi-Fi and hardwire Ethernet, you can figure out which adapter these things went through. And again, you get those bytes, you get those total byte sizes, which is really helpful when you're doing forensic investigation, because now you can tie into a specific application the amount of data that was sending back and forth and when it happened and which user context it happened under the system or on the system. So extremely useful. So some SRUM database conclusions. The Windows SRUM database helps us with identifying file execution, user attribution, activity correlation, and timelining of system events. And so now that we've tamed this through, I'm going to hand the mic back over to Tuan and let him talk to you about browser artifacts.
All right, so web browser artifacts, what they are, where they are, how they're important, and how do we parse those data out. What they are is basically browser artifacts are the artifacts that, left behind by your web browser or your favorite web browser on your machines, that every time you visit a website, your computer then store all this information for later use. Different browser will store their artifacts differently in different locations. Majority different naming conventions, more like folders wide, but they're very consistent. So why are they important? They're essential to digital forensic examiner and incident response. These artifacts help to identify the source of malicious attack traffics, where they go, where they've been. Also great for HR, insider threat, and other teams where they want to know, make sure you are doing any type of policy violations or not. So what tool do we use to extract the data and do the analysis? There's a lot of free open source software out there, such as the Browser History Examiner, Browser History View, Browser Download View from Neurosoft, DB Browser for SQLite, Hindsight. There's also various of third-party commercial tools for enterprise use. The artifact source coming from, such as the suspected hard drive, suspected workstation that people HR sending to you to do the analysis, forensic cloned hard drive image, memory dumped, or database or other file that user profile being dumped out for you to do the extractions. When we talk about the browser artifacts, we also want to talk about the high-value artifacts as well, most notably the history, type of URL, search, cache, login, cookies, form values, autofills, downloads, favorite, and then AKA, which basically the old bookmarks. We also want to talk about the private browsing. Private is AKA incognito browsing mode, which allow user to surf the web without retaining any type of artifacts on their workstations. While that's hard for forensics, but the only way for you to do that is during the memory dump in the live capture. So memory dumps are the snapshot of memory capture during the memory analysis or during the live triage. When a memory dump is captured, it's not only containing the running processes, it's also containing all the web browser artifacts too as well at that time. So you want to make sure you know the timestamp of the memory capture so you don't jump around in the wrong time frame. Here's the example of the high-value history URL. This artifacts navigation, basically provide the user where they went and where did they visit, such as malicious websites or not. As you can see, that is the tool from the Browser History Examiner. It will tell you the date, the title of the address, and the URL. It will tell you how many times the user actually hit the websites or not. Here's an example of the history artifacts path. Microsoft Edge and Google Chrome is basically the same, just different naming convention of the folder. Mozilla Firefox is a little bit different, but it's also there. Here's an example of the history parse out using the browser tool. Basically, you put in your time frame that you want, select the browser that you want to be investigated, and hit go. It will go to the endpoint, pull back the data, will provide to you the URL, the title of the URL, what time the user actually visit, and the profile that it was used. And it's also tell you what browser it was using to as well. You can also export it out to the Excel file for more details, to do your inspections and do the analysis. Provide the report to HR. You can also parse it out using the SQLite database browser too as well. Drop the table down, it will give you the row, and it will also give you the columns there. Same thing, it will give you the URL, the titles, the timestamps, and all that. Another high value artifacts are the typed address URL. These artifacts contain any URL that is typed into the web browser address bar. That means you can just basically tell that, yeah, Matt went to www.oisf.com. You can also find these artifacts also in the registry too as well. Here's an example of the type of URL being parsed out using the tool of the browser history view. You can see there, it tells you the URL, the title, visit time again, visit how often they went there, and how did they type it in. Was it typed the URL, or was it redirect, or was it one of those links that they click on? Also the artifacts from the registry there. Now with the registry, it's very limited, so make sure that, I believe there's only hold up to 50 count. So another one is the browser cache. It's containing cache data of various websites, such as the image file, the JavaScript file that's running on that website. Here's an example of the artifact path. And here is the cache parse using the tools of the browser history view. If you do any type of the image forensics or image investigations, you can tell it right away if, Matt here viewing any type of puppies or cats, or both. Download is also a very important artifact. It provides the file system location where the user file downloaded or saved. As you can see there's an example of the artifacts path. We can also use the SQLite database browser GUI to look at the download folder. Basically, it will tell you the download state too as well. If it's basically, this is great for malware analysis. If the user actually downloaded or not, what state it was it incorrupted, or was it downloaded successfully? Did they open and execute it or not? It will give you the timestamp and also the path of where it was stored. Here's another example of the browser download view. You can see there the file was downloaded, the download path of it, where it actually downloaded from, the time and the end time that it took to download. And then it will tell you if the user clicked it or not. So in the future trends, I anticipate growing need in performing for forensics analysis within the web browser, on a mobile device, and in the cloud environment. More and more people were using their device more than the workstation, so everything is on a mobile device. As we look toward the future, two trends are likely to emerge. Technology, e-business will continue to evolve. With that, the data privacy effort will continue to be a big challenge for us, for the investigators. Everything has to be privately. So it's going to be hard for everything will be stored on the workstation itself. Increasingly in cybercrime, creating new demand on talented forensic practitioner in this field will massively required. So in conclusion, while web browser play a pivotal role in the internet access, they continue being targeted by threat actors. As you can see today, all the speakers are talking about, web browser stuff. Analyzing the web browser artifacts will help the investigator understand the objective, method, and criminal activities, such as where did they go, what did they do, how did they download it, what time, and stuff like that. So examining a suspected system, the web browser logs detail remain a key artifact to most of the investigation. So with that, I'm going to give it back to the rock star. PowerShell, right?
Yes, sir. Thank you, Tuan. Appreciate it. All right, so our last thing we're going to talk about here is going to be PowerShell artifacts collection. These are PowerShell commandlets in, yes. Yeah, absolutely. The question is the link. If you want to get the slide deck, slides.dfirmat.com.
Yeah, we'll make them available. I'll make them.
Great. that'll take you to my GitHub repo. It'll redirect you there. Just go to the right year, the right conference, and you'll find the deck. Yes. All right. So PowerShell commandlets for digital artifact collection and e-discovery. The inspiration for this talk is threat actors are very fond now of using a common technique called LOLBAS, living off land, binaries, and scripts. And so we're thinking, hey, if offensive security professionals and threat actors alike can use these things, well, heck, so too, or is it too, can we? So yeah, we can play at that game too. All right, so my objectives are to leverage PowerShell to collect digital forensic artifacts from the endpoint being investigated. The presentation order that I put this in is based on RFC 3227. Join us at the Troll Pub. I'll tell you about my experiences with the authors of that RFC, and that's going to be a fun conversation. Not a long one, but fun. So anyway, the guidelines for evidence collection and archiving, specifically the section 2.1, which is the order of volatility. And a lot of times, computers are first in, first out. If you don't grab stuff in time, you could miss it. And so there might be some cynics in the crowd saying, well, Matt, the RFC says don't use the built-in tools and so forth. Understand that PowerShell is really the shell in Windows now. It's integrated into the OS. You can hash things out. So while the technology has changed, the strategies, the methodologies have not. So that's why I'm saying, yeah, you can use PowerShell for this in all likelihood for most purposes. So quick reminder, data preservation, really important here. We want to avoid running commands that will alter the system data and the access times. So to keep it as forensically sound as possible, mostly we're running get dash commands. We want to avoid importing or installing external or third-party modules for this. So as a quick warning, be prepared to defend running PowerShell as an administrator if you decide to do so. Now I'm going to talk a little bit about some potentially justifiable use cases why you might want to run PowerShell as administrator and be able to defend why you chose to run it with elevated privileges. PowerShell logging, this is really cool. So generally when you're doing investigations, you want to, basically timeline things. You want to log what you did, what the output was. Cool thing with PowerShell is it does it for you automatically. So the following syntax timestamps the start and end of our data collection process, and it also logs all the input and output results to a file for you. So you don't have to do it manually. You can use start-transcript, specify the path to the file name and the extension, and the -no clobber is just essentially append to the file. Don't overwrite the file, just append to it. And then stop-transcript will timestamp you're basically out of the file, the PowerShell log, if you will. So let PowerShell do the heavy lifting for you instead of manually timelining your stuff. Save you a lot of time and effort. The PowerShell version, helpful to get if you're doing an investigation. There's a number of automatic variables in PowerShell that store state information. Run the following to display the relevant PowerShell version information. And so your $PS version table will get you that. Also, if you're running a newer version, PowerShell 5.1 and up, it includes the PowerShell edition as well. So, good thing to run here. Just a quick note about PowerShell. It truncates lengthy text output by default. Think of these format-list variations as verbose output options. So, the pipe format-list gives you a little more verbose output. The pipe format-list asterisk will give you very verbose output, and your format-list property asterisk essentially is like very, very verbose output. And everything I'm talking about today, I would recommend using the very verbose output here. So append everything I'm talking about going forward with the pipe format -list -property asterisk to get full details, because when you're trying to collect forensic artifacts, you don't want to miss things. You don't have missing data. Where you're not getting everything that you want. System time is a lot where we want to start investigations. So we talked a little bit about the importance of time stamping, and sort of for the purpose of correlation, it's very critical for forensic purposes. So you can run the get-date to get the date, get-time zone to not just get the date and time, but also understand what time zone the system is working in locally. Because sometimes logs are UTC or GMT, sometimes they're one time zone versus another, and when you work in an organization that spans multiple time zones or internationally, this can get really hairy really fast. So I recommend getting that. The get-uptime-since requires PowerShell 6 or newer to get, but it's helpful. You can still do the hard maths if you're running a lower version of PowerShell, but that's super convenient if you have 6 or above. So get-computerinfo-property OS last boot up time is incredibly helpful, because then you can see when the system actually booted up. Get-computerinfo-property OS uptime is super convenient because it does the hard maths for you. Again, it literally tells you, okay, here's how long the system's been up and running. We talked about time zones, UTC, GMT time. Investigations are often easier when correlating timestamps using a neutral time zone of reference, which is sort of the nice thing about UTC and so forth. So if you use you can create a variable $time equals get-date, and then you can use the $time dot to universal time, and then basically it open start, close parentheses. That'll spit out the time in UTC, how it relates. Again, it makes it a lot easier going forward when you're trying to write reports, understand what happened when. Hashing files is critically important when you're looking at doing file analysis and so forth. So the get-file hash, you've got your file name and then -algorithm, and you got different options here. Probably the ones I use most are like MD5, if I just want to quick and dirty spit out what it probably is. MD5 isn't perfect, it's susceptible to collision attacks, those kinds of things, but for most investigative purposes it's fine. But if you really want to up the ante, you can use SHA-256. You can go even higher than that if you want. Just some different options there. Volatile network artifacts. These commandlets are useful for collecting the routing table, ARP, network traffic details, and DNS cache respectively. So get-net-route is going to give you the routing table. Get that -net neighbor, again, gets you that ARP detail. And then this can get a little tricky. So get-net TCP connection will give you the TCP connections that are active on the system. And since UDP is a connectionless protocol, the command is a little bit different. It's get-net UDP endpoint. So it's a little inconsistent, TCP versus UDP, but just be aware of that. And then get-DNS client cache is super helpful because that tells you everything that host has been resolving. So you can get the DNS details out of that. So processes and services. The following commandlets are used for obtaining a list of running processes and services on the endpoint being investigated, and they're just simply get-process and get-service respectively. Helpful to know what's running on a system and when. So then, again, this is based on the RFC, so there's some less valuable, or I'm sorry, rather less volatile network artifacts, and these PowerShell commands will get you those. So there's a get-DNS client, get DNS client server address to see where it's getting its DNS from. Get-net IP address gives you the IP address info for the NIC. And then get-net IP configuration gets you more details beyond just the IP address. And then get-net adapter gives you the physical adapter details, points to the driver, those kinds of helpful things. And then users and groups. Unfortunately, PowerShell doesn't offer a get-logged on users. I wish they did. It would be nice. Unfortunately, no. They don't have anything quite like that. There's a WMI query, get WMI object, Win32 logged on user, select antecedent unique. It's not perfect though. It might miss some things. I actually, even though it's not a PowerShell command, you can execute it in PowerShell. Query user, much better. Just run with that would be my recommendation. Get-local user group, pipe select star, shows you the local groups that are on an endpoint. Doesn't mean there's users assigned to those groups, but it's helpful to understand what groups are on the endpoint. And then the get-local user pipe to select star gets you all the local user accounts. Now that's not going to include like domain accounts that might be in one of the groups we talked about earlier, but it does get any local accounts that have been added to a particular Windows workstation. So that's really helpful. And then get-child item, the C:\users folder. It's not perfect because there could be something that removes those details, but generally it gives you a good idea of who's actually logged in to a workstation, whether it's a domain account, local user account. It's helpful to see, okay, these accounts are likely the ones that have actually logged on. Just because an account has access to a system doesn't mean it's actually logged into it. This just kind of helps you narrow things down a bit, which is why I put it in here and recommend that. PowerShell has different execution policy settings, so you can use the following to get the current execution policy and the policy for each scope in order of precedence. So get-execution policy, it'll tell you if something has to run signed scripts, unsigned scripts, those kinds of things. The get-execution policy-list tells you how those are applied, if it's a domain user versus if it's a local user, those kinds of things. Clipboard auto runs and tasks are helpful to collect, and so you can use these to retrieve text stored in the Windows clipboard, the get-clipboard. Now note, that's for the logged on user. So if you sign off a user account, you log in as yourself, you're not getting what you're probably hoping for. So this is, boils back to that live collection stuff we talked about earlier. You can also use get-sim instance Win32 startup command, which is super helpful because that tells you what's running on the system automatically. Of course, one of the first things any offensive security person or a threat actor is going to do if they compromise an endpoint is establish persistence. This kind of, that's a very common method for things that are automatically running on an endpoint. So this command will tell you what those things are. And then also scheduled tasks are another thing that get abused by offensive security folks, threat actors. Get-scheduled task will dump out the scheduled tasks on the endpoint, which can be really helpful later on for analysis. So host details, you can use the following to collect additional details such as installed drivers, programs, hotfixes, disk drives, system details, and other OS information. So the get-windows-driver-online-all, that's one of our use cases for running it as administrator. You have to run as PowerShell as administrator to get those details. Why would you want drivers? Well, modern day rootkits, one of the most common methods for that is through drivers. Basically, this will tell you what drivers are, on a system. So that's why that can, just one example why that might be helpful. Get-package tells you all the Microsoft, all the software that's been installed on the system through normal means. May not get you, for example, self-executable programs that aren't actually installed, portable applications, if you will. But the things that have been installed, it'll get. It can also see what hot fixes have been applied to a system. Might be useful in understanding if something was compromised. Was it patched? Were we missing an important hot fix that may have prevented this? Get PS drive tells you about the physical drive, disk drive, as it relates to the Windows OS. Again, it's just good, useful information to have. And then the get-computer info gives you all kinds of stuff. Computer names, domains, that's where the time stuff is stored, for boot times, all that kinds of stuff. There's a ton of info in there. So I do recommend getting that. Now, here's another pain point. If this was possible, it would have been earlier in the slide deck, I promise. But there's significant challenges in obtaining a list of open files on the system. Like, other than when it gets to fileless malware, like this would be really great stuff to have. So you can use the get-smb open file, but it only shows files that are open from that endpoint from the remote system, not what's locally running on as the local logged on user. And also, that's another use case for running PowerShell potentially as administrator, so you can run that command because it requires it. Now, here's what's awesome. There is an open files/query that would give you exactly what you want of all the open files on the endpoint. Here's the caveat. If you run it by default, Windows is going to say that the system global flag maintain objects list needs to be enabled to see the local open files. So you might think, well, I'll just turn that on and rerun that command, right? No. I wish. So the open files /local on actually does turn that on an endpoint. Again, that also requires those elevated administrator privileges. However, you have to reboot for that to take effect. And of course, once you reboot the system, all the volatile data that was in memory, for example, like a lot of stuff disappears. Forensically, far less than ideal. Now, you can proactively turn that on. I will tell you, there is a performance hit on the OS for doing so. How is it going to impact your workstation? Can't tell you that. You really have to do your own baselining to determine in your organization if you want this to be the standard, what is it going to impact? Can we put it on, certain groups, for example, not others? You just have to experiment, baseline, and see how that plays out. But it is super helpful to have if you do have it, obviously, because you can see any file that was open on the endpoint. Super helpful. So this just barely scratches the surface on this stuff. But the more PowerShell tips and tricks from Microsoft themselves, some great further reading here. Learn.microsoft.com, and you can see the /enus/PowerShell. All kinds of good stuff. In particular, a lot of the stuff comes out of the module Microsoft PowerShell.core page. Again, get the slide deck. You can check these things out and learn plenty more about PowerShell that is way out of scope for this talk. So, want to thank everybody here. I am going to open it up for questions and answers. And again, if you want a copy of our slide deck, slides.dfirmat.com. Feel free to hop out there, get this. It's got all those PowerShell commands in it. Okay, good deal. Any questions? Yes.
For those